Unit 10, Day 2, starts out by introducing you to two new terms. One of the terms is called the angle of elevation, and the other term is called the angle of depression. Both of these two terms are related to a person's line of sight. So if you are here and you are just facing normal front, your line of vision goes this way. It has a horizontal line movement to it. If you were to look up at something, let's suppose you see a rainbow in the sky and you look up at it, your angle of your eye line of sight is going to move up to look up at the rainbow, and you are producing an angle of elevation where your eye line of sight lifts to look at the rainbow. If by chance you are standing here, let's say, on the top of a building looking out, and you looked down, let's say, to see a cat that you saw on the ground, your line of sight would move in this way, creating an angle of depression. So if we take a look at the combined picture here, where there's an angle of depression from somebody up on the top looking down at somebody on the ground down here, in this picture, both of the lines of sight start out to be horizontal. The person up above tilts their line of sight down to look at the person here, creating this angle of depression. The person on the ground tilts their line of sight upwards, creating this angle of elevation to look at each other. These two angles, angle of elevation and angle of depression, are equal to each other because we assume that the lines of sight are both horizontal, therefore parallel. So in either case, the angles of elevation and depression will be equal to each other. So if we're taking a look at example number 1, and we see that Scott, whose eye level right here is 1.5 meters above the ground, and he is standing 30 meters away from a tree, his angle of elevation to the bird at the top of the tree is 36 degrees. So this angle is where his line of sight moves from. They're asking how far the bird is above the ground. So we're technically looking for an x value right here to add to the 1.5 right here to get the total height of the bird. I'm going to label the total height of the bird as y and put a note here that it's equal to the 1.5. So in this picture, I technically am dealing with this right triangle that's right here, and I'm going to work with that, use my sine, cosine, or tangent. In this case, it's opposite over adjacent, so it's tangent of 36 equals x over 30, and then I'm going to go through and solve this. So 30 times the tangent of 36 which gives me 21 point, and then remember, with the Regents exam, you always write out the whole decimal. Even though it says to round to the nearest tenth, we don't do that until the very last step. So my x value is this, but that wasn't my final answer. My final answer is, what is the height of the bird from the ground? So I have to add on this additional distance above where the line of sight is. So I'm going to take this x value, substitute it in right here, so I end up getting 36.79627,584, which when rounded to the nearest tenth now is 36.8. And again, you can see I carried that long decimal all the way to the end, and I did my rounding right at the last step. For the next question, it's talking about an angle of elevation, an angle of depression of 40 degrees. And this is saying from an angle of depression of 40 degrees, John watches his friend approaching the building while standing on a rooftop. It kind of should make sense that that is the case, because an angle of depression will always be kind of going in the downward direction like this. So up at the top of the building is John, and then over here is his friend. And it says that the rooftop is 16 meters from the ground, and John's eye level is 1.8 above the rooftop. They want to know what the distance is between John's friend and the building to the nearest tenth. So this is what they're looking for. In this case, I'm going to draw in, whoops, that kind of drew that a little wrong. Let me fix that here. I'm going to draw in the triangle, and the triangle goes right up to John's line of sight. Here's where he originally was looking, an angle of depression right here of 40 degrees. In this case, this edge of my triangle, this side of my triangle over here, is 17.8. So in this case, I'm adding on and making the triangle bigger than what I did in the last picture. So the triangle that I'm working with here is this triangle, right angle, side of 16, side of x, and this angle of 40 degrees by alternate interior angles ends up coming inside the picture. So in this triangle, this is the opposite over the adjacent, therefore tangent. So tangent of 40 equals 16 over x. When I cross multiply and solve, I get 16 divided by the tangent of 40. So 19.06805,748, rounded to the nearest tenth because that's what this question asked me to do. Question 3, standing on the gallery of a lighthouse, that's the upper deck of the lighthouse, a person spots a ship at an angle of depression of 20 degrees. So I need to kind of draw a little lighthouse here. Remember, doesn't need to be anything fancy. And it says that there's a person standing up here and they spot a ship with an angle of depression of 20 degrees. So I know that somewhere up here I'm going to have this angle of depression of 20 degrees. It says the lighthouse itself is 28 feet tall, meters tall, and then it sits on this cliff that's 45 meters tall above the sea level. They're asking what the horizontal distance is between the lighthouse and the ship. So my ship is going to be over here. And I'm looking for the distance between the lighthouse and the ship, the horizontal distance from here to here. So this is where I'm going to put an X. So in this particular picture, I am looking at the right triangle that does this. This side is 73 because I add the 28 and 45. This side is X that I'm looking for. And this angle of depression that's right here, I can transfer down here so it's inside my triangle. Line of sight and the water level are parallel. The angles of 20 are the alternate interior angles. So from this particular picture, if I'm looking for X with respect to my 20 degree angle, opposite, adjacent, again this is tangent, so in this case the tangent of 20 equals 73 over X. X is equal to 73 divided by the tangent of 20, which gives me 200 point. And actually they were asking for the horizontal distance, did not say to round, so this becomes my final answer in this particular question. Notice how in this question the height of the person was irrelevant in the problem, so we know that there's a person standing up here. Their height though is irrelevant, so they're not tall enough with respect to this side of 73 feet to even make much of a difference when I'm measuring how far the ship is from the foot of the lighthouse. In the question up above though, in a 16-foot building, almost another 2 feet on top is going to affect the outcome of the answer. So sometimes we consider the height of the person and sometimes we do not. You have to go by what the problem says. In the question on the top of page 8, we're talking about tangent. And it's kind of hard to see in this picture what it is that's going on in here, but essentially there's a line that goes here and there's a line that goes here. And in this particular question, when we go through and do this, it is saying that we are taking a look at the angle of elevation and the angle of depression on a coordinate plane. They want to know the slope of this line. So for the slope of this line, I know that when I do slope, it's how much I go up over how much I go over. So slope is going to be change in y over change in x. So in this case, up 4 and over 8. So up 4 over 8, which gives me a slope of 1/2. When they say what is the tangent of the given angle, the tangent is the same thing. If we consider this triangle that's right here, and this is the angle that we're looking at, we know that this is 4 for the opposite side, this is 8 for the adjacent side, and if we were to go through and find the tangent of the angle that we'll call theta, which is right here, it would be 4 over 8, which is also 1/2. Essentially what they want you to notice here is that the slope of the line is the same ratio as the tangent of the angle. So if I do slope up 4 over 8, or I do tangent of this angle 4 over 8, they are the same. Because this angle is elevating, it's considered to be positive. It's going uphill. With respect to that, we could also do the angle of depression in a picture. So we can see that we have the x-axis right here, and I have an angle of depression that's right here. In this particular case, when I go through now and I consider the way that that line is tilted, I know that it's going downhill, so the slope of the line is going to be negative. That makes sense because an angle of depression is negative also. In this particular question, my starting point is here. I'm going to pick this point. It's kind of hard to see on the graph, so if that's the case, I'm going over 1, 2, 3, 4, going down 1, 2, 3. So in this case, for my angle of depression, I know, I'll kind of draw this in, for my little triangle that I have right here, that the tangent of that angle is going to be 3 over 4, opposite over adjacent, and if I do the slope of that line, the slope of this line is going to be up 3, left 4. So if we take a look at the fact that there's a difference in signs here, what we need to acknowledge is the fact that because this is an angle of depression, it's going to be our job to put a negative on this answer. It should make sense because if we do the slope of this line, up 3, left 4, we can see that that has a negative slope. So it's our job to know that if it's an angle of depression or a downhill line, that we need to take the negative of that tangent value. If you take a look at question number 4, they're asking for us to find the slope of this line correct to 4 decimal places. So we know if we're finding the slope of the line, it's going to be the change in the m distance over the change in the n distance. So the way it changed here over the way it changed here. Basically, that's change in y over change in x. Now, if we're looking for the change here, remember, if it's m over n, we know that in this triangle that we have here, with respect to 36, this is opposite over adjacent. So we know that the tangent of 36 is equal to m over n. All of a sudden, at this point, this m over n becomes irrelevant because if we know the tangent of 36 is equal to m over n, on our calculator we can just type in the tangent of 36 and get that answer. So without even having to count those side lengths, just knowing that this is here, we can go through and do that. Now, keep in mind, this is a negative angle down here. It's a downward facing line, so that means that we've got to take the negative of that. Most of the time the negative's put back at the beginning in front of this tangent of 36 negative tan 36, and type it into our calculator. So correct to 4 decimal places is going to be negative 0.7265 for the final answer.